Hey everybody, Don Zoldi here, your host of the Don Autonomy podcast and the CEO of P3 Tech Consulting. It's June and we are celebrating the theme of complex ops. And our sponsor this month is uAvionix, because when you think about the complex ops happening out there, these guys are all over it. And we have with us today Brit Wanick, who is with the company, and we are so excited to have you back on the show, Brit. Brit has been a real supporter of this show, and we are honored to have you guys as this month's sponsor.
Well, thanks, Don, and certainly happy to be here. And yeah, complex operations is definitely very familiar with, and whether it be waivers, exemptions, flight operations, defense, civil aviation, you name it, we're in a lot of those spaces. So excited to be a part of the show today.
Absolutely. And just a reminder, everybody, we are live. And so please, please, please jump in the chat, say hello, tell us where you're from, what you're doing. And of course, ask Brit those hard questions, because that's why he's here, to answer those questions about how you can also get these approvals for complex operations with your drones. So anyway, let's jump in, Brit. And not everybody knows you. So could you give us that kind of 30-second elevator background pitch?
Sure. So, myself, I'm Brit Wanick. I'm the VP of Marketing here at uAvionix. Been at the company for about 2 years now, and super excited to be a part of this growing organization. uAvionix itself started back in the 2015 timeframe, really with the idea of how do we make it so that drones can be seen by crewed aircraft. And so that concept of ADS-B, a way of being able to communicate your position out, was something that we brought to the market. There was a little hiccup there in the fact that it didn't really work from an FAA perspective. And so the team said, well, hey, if we can't make the drones be seen by the crewed aircraft, how about we make the crewed aircraft be seen by the drones? And boom, we stepped right into the ADS mandate. That kind of launched the company, and we've grown ever since in a variety of ways. But really focusing on our core superpower, if you will, is rapid innovation, a focus on safety, and a focus on efficiency across everything that flies. And that includes defense, that includes crewed aviation, uncrewed aviation, and then even more recently, working what I would call aviation data as a service to be able to support all those constituents in the space. We're excited to have a good year ahead of us here, and looking forward to the opportunity to talk with you today.
Yeah, I mean, like I said, everybody, these guys are all over the place. So you just heard general aviation, UAS, uncrewed aircraft systems, defense, commercial side, all of it. And we have a really quick video I want to roll to highlight some of these products. So let's go ahead and roll that. All right, we're going to go through all of these products. And by the way, we do have someone jumping in the chat right away, so that's amazing, Brit. We've got Mark Ginnog from the Nevada UAS test site. He is a super fan. We love Mark. Great to see you out there, buddy. Thanks for chiming in. Appreciate you. So let's, we talked about the problem you were trying to solve, but I want to kind of jump into these products because you have so many new developments since we talked last year. And, when people think about you, they do think, I think initially, at least kind of in our crowd, right? The UAS crowd, they think these guys are UAS focused, but you have a rich and deep history in general aviation. And most recently, you have provided surface situational awareness to air traffic control towers across US airports. I saw that announcement and I'm like, holy shnikes. So tell us about this, and how does that fit into kind of this larger ecosystem that you all have curated over time?
Great, right. Yeah. So, we've got a rich history in understanding ADS-B, right? And both the broadcast of that as well as the receipt of it. So it was a natural extension as we, use that leverage, if you will, from an understanding perspective to deliver something to air traffic controllers, essentially at underserved airfields, to really help with collision avoidance, right? In this case, The focus was on collision avoidance between aircraft, potential vehicles on the ground as well that are part of the airport, and within the radius of the airport itself. And so we're very pleased to be a part of that program, the Surface Awareness Initiative, with the FAA. But everyone looked at it and said, well, what are you guys doing over there, right? What I thought you were coming out with UAS, or I thought you were developing displays and the like for the general aviation community. The reality is that capability, right, which is able to detect aircraft, essentially, in this case, cooperative aircraft, is very key to us enabling drone corridors and other operating areas and centers where we might be trying to do drone delivery services, or perhaps we're launching a drone as a first responder program. And what's important about it is that this is something that's coming from the FAA, right? They went through a very, very rigorous test procedure with us, a very rigorous proposal procedure to say, okay, we trust in this, and we're going to allow this to be deployed at these control towers, essentially. So we're taking that pedigree, if you will, and now we're going to be able to pivot it into what we can do for the uncrewed space. And it's a benefit to the crew space, right? So really striving to achieve this integrated capability that's both safe and efficient. And the opportunity with SAI gets us into that market very quickly. There are over 200 airports at which this could be deployed at. Don't have them yet. It's going to take a little bit of time, and my team is very rapidly out there in front right now making those deployments happen. And I expect to have some good announcements about those launches here within the next coming months.
So Brit, it's called Flightline.
Yeah.
And so my question is, because you said it's between cooperative air traffic and also it can detect ground traffic. It frightens me a little bit because I'm thinking airports, I'm thinking, what did they have before? And, or did they, because you said maybe underserved smaller airports.
Yep.
So maybe like when I think of Newark International, they've obviously got something going on there, we hope. But you're filling a gap. Can you explain kind of the gap that you filled? Because in my mind, I just always assumed that they already had something like this.
Sure. Yeah, so there's ASDX, right, which is a program that's been around, and it services the larger airports, and it provides a very similar capability for them to be able to track vehicles, airborne and ground, around airports. And that's a relatively enterprise level capability that's been deployed by the FAA, right? And it's operational today, and it keeps us safe in the skies.
Sure.
But when you fly into someplace, like our home airport over at Leesburg, or even up in Kalispell, right? You're limited there essentially by the tower, and that's why we have air traffic controllers. And their responsibility is to use the available systems that they have. In some cases, that's radar. In some cases, it's the visual eye, and then the communications with the aircraft themselves to be able to control the airspace and make sure that things don't happen in a bad way. Yeah. Essentially, this then comes in and provides an additional level of support for them by showing them the real-time air traffic in the area from aircraft that are broadcasting on ADS-B or via ground vehicles. So, Ops 1 or Ops 2 is out doing a FOD check on the runway, and it happens to be at night. Well, we can now see those vehicles on the runway, and that's something that's provided by what we call a VTU, a vehicle tracking unit, essentially an ADS-B broadcaster that goes on the vehicle itself. And more importantly, if you look at some of our partners like ForeFlight, if I have the ability to collect that ADS-B traffic in the cockpit, so say via Sentry, right, I can actually then display that on my ForeFlight, my iPad in the cockpit. So I'm in my Cessna 172 coming in for a night landing. Ops 2 is out on the runway doing a FOD check. And yeah, I've worked with controller, it's all lined up, but I can now get an alert on my iPad that says, hey, there's a vehicle on the runway when you're approaching.
Wow.
Right? That additional situational awareness for the operators, for the pilots, is a significant advancement in safety. And it's not that we didn't have things before, it's just that we now have technology that can really help the situation, especially in a case when you've got significant amount of load on those air traffic controllers in the airports themselves. And we're adding more and more aircraft into the scenario, right? It's not like that's decreasing when you add uncrewed aircraft, crewed aviation, right? There's a real need there to be able to get this in place. And obviously we saw quite a bit of news potential collisions. And so that was a good impetus and opportunity. And the FAA came asking for some help, and we were ready to deliver.
Okay, okay. Wow, a lot going on here, including in the chat, by the way, Brit. And so,
Yeah.
I mean, Greg Larson is saying hello from Augusta, and we also have Living L6S. Hello from California. Lots of love, Dawn. Love right back at you. So thank you so much. Okay, wow, that's incredible, Brit. So as I'm listening to you, you kind of alluded to it, but we're going to talk about the future a lot more later in the show. But you're thinking, you know, layering in UAS into this. As I'm thinking through this, obviously, we see Joby out there, we see Beta Technologies, Lilium, the list goes on of air taxis or electric vertical takeoff and landing or the STOLs and all of these kind of newer aviation aircraft. These will all be layered in at some point, maybe vertiports, maybe airports, what about, and helicopters too?
Yep.
Okay.
Yeah, certainly. I mean, helicopters can have, they can be cooperative and have ADS-B out. Many of them do. We have several that actually fly with tail beacons and tail beacon X's as well. So yes, anything that flies essentially that has that type of ability to produce ADS-B can be collected by the ground-based receivers that we have and then displayed back. And uniquely, this flight line capability that we have is tailored to the Surface Awareness Initiative, right? Effectively is a cloud application, right? So we deploy hardware that goes on into the field. Essentially, it's 2 antennas, so there's redundancy that comes back into a cloud-based architecture, and then what the controller uses or the operator uses essentially is a web application, right? So we can very rapidly deploy and inside a tight line window, and it's not a significant cost that's then levied on these operators because essentially they just need to have a screen in the tower, right?
Yeah.
And so it makes it very easy for that data to be available. The other thing that's elemental here is that we own and know the network, right? So we can track the pedigree and the provenance essentially of that ADS-B data, right? So there's a lot of validity that can be brought into that, and we can do certain things with the math that make sure that, yes, that really is a specific aircraft target. We've called that True Sky in the past. That's a module that's a part of Flightline. And that additional validation of that ADS-B traffic eliminates spoofing and ensures that, yes, I as a controller can trust that data that's there when I'm using it as a part of my situational awareness and I'm using it as a part of my decision-making process, right? So that element is something that we can deliver as a service today, not just to the FAA or airports that are part of the SAI initiative, but it's certainly going to be available to others in the UAS space that are trying to operate at scale, right? And when you try and get to a point where you don't need a visual observer or you just have an electronic observer, this type of technology, this type of service is a core competency we can deliver for you and allow you to go off and do the business that you would like to do, whether that's emergency services, medical supply delivery, or, land mapping, or whatever it might be that you need.
Yeah, so we have a comment from the crowd, kind of like TCAS, or how is it different, or is it the same, similar?
So TCAS takes into account a certain set of avoidance maneuvers, right? And this, in this essence, is just situation. It's advisory information. Now, what the operator chooses to do with that is obviously up to them. We make similar products from a TCAS perspective. If you were to look at something like our Ping RX Pro that goes onto an uncrewed aircraft, that is typically then fed into an autopilot, and there may be a portion of the autopilot that's configured to do an immediate avoidance maneuver. Right,
so for beyond visual line of sight, kind of thing. So everything you're saying about Flightline, I hope my friends in Abu Dhabi and UAE are listening to this because, I feel like they are going to be on the forefront of the air taxi world. Every time I turn around, there's another company signing with them. They're, building vertiports, and of course, everybody else that's thinking along these lines from an infrastructure standpoint. Infrastructure, is digital too. And it's not just building, like a flight line or a vertiport. It's how does it all operate together? And this is a critical part. Now, you mentioned, you're part of this ground-based kind of surveillance initiative with the FAA. You mentioned that it's the ground-based hardware that you have that provides the information in part to this system, Flightline. Is that your CASIA G that we're talking about there, or something else?
Great question. Great question. So we've been talking about the cooperative aircraft, right? Those that are essentially broadcasting ADS-B. But as we know, not everyone is equipped with that, and not everyone currently is required to be equipped with that. So, and there are other flying vehicles or objects or aerial systems that may or may not have ADS-B, or not what we would call electronically conspicuous.
Yeah.
Enter Cassia G. Cassia G came to us through the acquisition of Iris Automation back in the October timeframe of last year. It is a computer vision system that can optically detect objects and classify them in the sky, right? So it's looking for non-cooperative aircraft. The good news is that it also has the ability to receive ADS-B, has some of our same technology in it. So now we're able to correlate those two things together to get a validation of both the cooperative and the non-cooperative, right? That provides the operator, whether you are, operating for a pipeline inspection or delivering across a cityscape or doing something for drones as a first responder from a police department, that is what gives you, in many cases, the ability to operate beyond visual line of sight, because you have both cases covered. And that's very critical to evaluating that safety case and that risk case that then the FAA would give you approval to operate under.
Well, I've been working with Iris for years. I was so excited when I saw that you guys had partnered up and John Damish had become he's your CEO, right?
Yes.
Yeah,
Yes.
huge fan of John. Like I said, worked with him for several years. Very familiar with the Cassia kind of ecosystem, including Cassia G. So man, you continue building and growing this ecosystem, and it's really phenomenal. Now, we're talking about ADS-B, and we both know not all drones are going to have them. They're not required. In fact, kind of prohibited unless by exception or whatever.
Yeah.
But I guess how you look at that. But you created very small ADS-B because for complex operations, our theme for this show and this month, you kind of need that on board in some respects. And so tell us about how you were able to create the smallest ADS-B transceiver to work on these drones, to get them flying these complex ops like BVLOS, and kind of what are the different iterations? You mentioned ping RX, I think, but you have a lot of different pings. So tell me about your pings.
Yeah. So the Ping brand, essentially, if you will, is kind of the evolution of ADS-B out. And as I mentioned, kind of our origin story was like, well, how do we make these things that fly visible to the crewed aircraft? And yes, there are some prohibitions unless you're actually communicating with HC and the like from having ADS-B on UAS, but it certainly is something that we do make and deliver. And why the small size, weight, and power? Well, again, that's one of our superpowers, right? We like to take a very big challenge when it comes to technology and figure out how to fit within a format that doesn't disrupt the size, weight, and power needed for the mission of the aircraft, right? If we came out with a typical transponder that you might see on a commercial aircraft or even on a GA aircraft and said, yeah, we're going to drop this on a 0.5 kilogram drone, well, you just took away all the payload, right? And so
Yeah.
you now eliminated the ability of that device to be able, so we really had
or even maybe to get off the ground, depending on the
yeah,
drone.
exactly. If you did, it'd be very short. So you had to kind of approach the problem from a different perspective, if you will, a little bit orthogonally. We have very, very strong technicians on the team and technologists that have been involved with RF technologies for a very long time. Paul Beard being kind of the of all that from a spectrum perspective. And so with that knowledge, we've been able to create these initial ADS-B devices that are very lightweight, very small, and then expand off of them, both from a receipt perspective as well as from a broadcast. The other element that's key is, it's one thing to be able to broadcast where you are, but you also have to know where you are, right? Mm-hmm. And so we've done a lot to really understand what it takes to have a high integrity, high accuracy GPS that's very small in form factor as well, that can be paired up with one of these devices. So when you look at something like our Ping 200X, which is a TSO device, right? So it's got an FAA TSO associated with it. We also have a GPS device that goes along with that. So you can validate essentially that you've got the right position information that's being broadcast by that. That package together and creating that solution set is what really helps us move in the marketplace and give somebody the means that they need to be able to build it into their aircraft and then accomplish their mission.
So you're talking about GPS, and oh, by the way, I'm going to squirrel. L6S is Karina Passy from LinkedIn. Karina was one of our scholars for Law Tech Connect this year, so thank you, Karina. Thanks for being out there. Now I know what your, I guess your little sign is out there, living L6S. So you're talking about GPS, and I've been doing a lot of writing about GPS. And Britt, you and I have just watched the world, and we've seen challenges, spoofing, we've seen jamming, happen in war zones and other places. I've written about this for Inside GNSS magazine. Are there, so GPS obviously is so critical to everything we do, including obviously aviation, drones, general aviation aircraft. The DoD, they have a special, kind of RF spectrum that they use. Do you have, are you using other satellite, in other words, for locational data? Do you have other things in addition to GPS that you're incorporating into your ecosystem? Are you looking forward to that?
Well, I'll offer this, that we're very much looking into the variety of different ways that you can come up with a complementary precision navigation and timing.
CPNT.
CPNT, right? So there are, in the U.S., we have the benefit of a significant amount of ground infrastructure, and there are tools and technologies out there today. Multilateration is not necessarily a new math problem, right? But we have devices deployed in many aircraft, and on the aircraft, we have AD on the ground. We happen to know where those things are. It doesn't take too long to figure out that, yes, we can actually come up with some complementary ways of knowing where the aircraft is and validating that GPS output is correct. But there are other methods that go beyond that. We don't always have that ground infrastructure. So you mentioned satellites, right? Yeah. And obviously the low Earth orbit satellite constellations that are coming to bear all have signals emanating from them. They all have time differential that we can manipulate and utilize. So yes, we're definitely looking at that. Yeah, I wouldn't say that we have a product today, but it's certainly something that we are aware of and is part and parcel of what we're trying to deliver into that ecosystem. And it all ties together, right? You kind of have to have knowledge of where you are, where you're going, and control over that aircraft over a long range. And so what we're focused on right now is let's make sure we have the redundancy in place for command and control, right? So that even if we do know where it is, or if for some reason it feels off, we can get it back on track. And that's what you're seeing as far as what we're rolling out with assured command and control, our multi-link, what we're doing with Skyline, which is what we talked about last year, is really optimizing that for beyond visual line of sight operations, where you might then run into an issue with regard to the GPS and its signal loss.
Okay, perfect. No, that's a great explanation, and it doesn't shock me that you guys are at the cutting edge of CPNT. I've been tracking that arena for a while now. But let's talk about, you mentioned your assured command and control, and I want to get to that in a second. But before we do, since we're talking about receivers and transponders, you've got the ZPX1 combined transponder receiver. Tell us about that.
So ZPX1 is really an evolution of a device called the ZPX, which was the initial, essentially, Mode 5 IFF transponder that we have. The Future Tactical UAS program out of the Army has some very specific requirements, and the recent AIM certification with the ZPX1, it's the only device designed to meet those requirements, which is a great benefit to both Textron Aviation as well as Griffin that are operating under increment 2 there, right? So this unique device is a combined transponder and receiver for both ADS-B and Mode 5, right, which is the IFF, which is essentially a military way of essentially identifying an aircraft, so Combine ID. And there are new modes, in particular Level 2 and Level 2 broadcasts, that have been released under Mode 5 that this device supports. So it boils down to being able to have a greater amount of battle space awareness for both crewed and uncrewed aircraft, right? And when you look at programs that are being bannered about, whether that's the Replicator program in the US or what's happening over in the Ukraine, understanding what, right, and being able to identify friend or foe. So this device, as it goes into these military programs, as both a combined transponder receiver, puts together in one package, one device, an incredible technology and an incredible amount of capability that is then deployable in these drones essentially, right? And it could also be something that's utilized on the ground, but it's a small package, right? When you look at that device on the image that came up, it's smaller than my phone. Let's just say that, right? So it's not a very large device itself. And that allows you to preserve payload, preserve operational mission, preserve power, et cetera. And that's really the benefit that we're having there. We've then extended off of that to other elements within the ZPX line, right? So there's one that's just a receiver. There's obviously the traditional ZPX itself. And then we also help companies with being able to provide some of the support to do crypto testing, which, cryptography and IFF, they go hand in hand.
They do.
And that's typically a pretty heavy cost. And so we provide essentially capabilities for them to do that testing well ahead of deployment that doesn't get them into the crypto realm of having to manage that, so they can get through their testing faster and get their approvals done to be able to move into production essentially.
Well, for everybody out there, if you've maybe just kind of have a little bit of a disconnect here, we just did jump into from the commercial sector that we've been talking about to more the defense side. So IFF, identify friend or foe, is, as Brit said, what they put on aircraft to know, hey, is that a friendly or not? If it's not squawking and there's a cryptography aspect of this, involved, then, assume it's a bad guy. It's not one of yours. And, Brit, when you think about what happened at Jordan Tower 22, the tragedy there, first time, by the way, everybody, in over 70 years that ground troops, U.S. ground troops, were killed from something, in basically in the air. And I'm not talking about missiles. I'm talking about aircraft. That's significant. And, when I think about what you're doing, Brit, and, obviously there's other companies doing this kind of work as well. Why the DoD and like all of our coalition partners don't have these things on their aircraft right now is mind-boggling, because this is one of those things where, if I'm the JAG and I'm standing side by side with my commander and one of them squawking and one of them isn't, it's a no-brainer. It's like, take that one out. And I think something like this would have avoided the tragedy that we did see. And I hope people in the DoD, in the acquisition community, DIU, I hope you're listening right now, because to me, this technology is a no-brainer, and I don't know what they're waiting for. The other thing is, of course, and Brit, you were talking about complex operations, which all military operations are, let's face it. This idea of counter UAS. I know you're not like deep in the space, but like, frankly, the connection between what you're doing with this ZPX combined transponder receiver, counter UAS systems that can incorporate all of these things, right? To like, hey, especially as more autonomy gets included, to me, it all makes sense that this is part of that ecosystem. So yeah, more to follow in the future, but I love what you're doing. This is so important, I think, for the safety and security of our forces and our partners. And that's all. I'm going to get off my soapbox, but thank you for that. And we have a question from Karina. She says, Brit, are you talking about sharing frequencies like C-band and KU band?
Sure. So the good point there. And I think you might be referring to what we're talking about in that C2 space, that command and control space, right? So we do have a device called multi-link. The multi part is actually LTE, which is yet another frequency essentially. But if you think about it, when we approach command and control, we look at it from a multi-path and a multi-frequency perspective. And there are a variety of ways that aircraft today. So I'll give you one example. Is I could fly an aircraft that could be relying on LTE as a primary communication, and they say, well, that LTE might fail, and so I add another LTE radio. Well, in that case, I really haven't changed the modality by which I'm communicating. I just have some redundancy in this. The other thing is to say, well, no, I actually want to use LTE and aviation protected C-band, right? Or I want to use LTE and ISM and C-band, or in the broadest case, I want to use LTE I want to use ISM, I want C-band available, and as failover, I want to be able to connect to Starlink, right? And so the equipment that we're developing from an airborne radio perspective is designed to connect to each of those different modalities. And then the Skyline system that we talked about early last year has evolved from kind of this initial focus on LTE and C-band to being able to optimize across all of those. So for the operator, that system is cloud-based. It's constantly looking at what the signal strength is for each one of those, connecting to the aircraft, understanding what the trajectory of the aircraft is, and then ensuring that you're on the right signal to maintain positive control of the aircraft. So it's always a make before break with the radios between the ground stations and the airborne radios themselves. And that ground station could be essentially an LTE tower offered by T-Mobile or British Telecom. It could be your own deployed C-band radio that you attach to a DeWalt looking type battery that you deployed in the field because you got to go do fire department operations to put out a forest fire, or it could be Starlink that you're connecting back on, right? And each one of those modalities and capabilities has with it its own service levels, has with it its own pros and cons. You as an operator want to be on the best one at the right time to do the right thing, and that's what the system is providing essentially. So I definitely believe in being able to pull together kind of a multitude of different frequency bands for whatever the right mission is. Obviously, we're a big proponent of C-band as well. It's protected for aviation. We think that's a good path forward to be able to maintain positive command and control and still allow room for payload consideration. I need to get video back. I need to get imagery back. I need to get, sensor data back. Well, we have other modalities that we can do that with. Aviation protected C-band then stays in the C2 lane and lets you operate the aircraft safely.
Okay, yeah, that makes a lot of sense. And you mentioned LEO satellites. You just kind of mentioned Starlink. Everybody knows about Tesla, Elon Musk and Starlink. But Viasat is one of these companies that is really laser focused on this space. When I say this space, UAS, I met them actually last year, commercial UAV. Fun fact, Brit, they are actually sponsoring next month, Global Leaders Month. So, and you at uAvionix have partnered with Viasat as part of this overall assured and command and control project, if you will, or ecosystem you're creating. So tell us a little bit about that.
Yeah, so we've been working with Viasat for a while now. Actually, I think it was part of one of the first test flights back out in Montana, would have been essentially this time last year or even earlier. And they have a different approach, obviously, on the satellite space between their recent merger with Inmarsat as well, where different constellations available, whether that be GEO, MEO, and LEO, and access to them, right? So depending upon where you're flying in the globe, you may have a different need that's better met by Viasat, or another person or another company that we're working with actually is Iridium, right? Iridium has its own services too. So we're not necessarily wed to any one particular service, but we're certainly partnering with those major providers to be able to meet the needs of our customers. And what it's giving us is perspective on, okay, this works really well in this situation. This works very well in this one. And we aren't yet at a point where we have a ubiquitous infrastructure when it comes to satellite communications, and nor are we with kind of normal operations from a UAS beyond visual line of sight. So that knowledge level that we can bring to our customers and help them steer towards an appropriate solution across all those partners is one of our core competencies that we're helping out with. And as we go into places, like what we're doing in the test sites, or whether we're helping with drone corridors, or what we're doing down in Texas or at Choctaw and those locations, that knowledge level is really helping customers kind of advance their programs and achieve visual line of sight beyond visual line of sight operations much faster than them kind of stumbling through it themselves. Because we've done the hard work of working out what needs to get done.
Well, it makes sense that you need to be kind of agnostic when it comes to space, because it's a big area and there's a lot of companies out there, and to be able to plug and play into whatever satellite's needed whenever you need it. And by the way, everybody, LEO, we already said low Earth orbit, MEO is middle Earth orbit, and GEO is, oh my God, geostationary. Yeah, wow, brain, Earth orbit. So we're talking like really, really, really high up. So that's awesome that you're working with all these kinds of companies to give people the best solutions depending on what they're trying to achieve. Now, multi-link, or as it's spelled, by the way, everybody, MU capital LTE lowercase LINK, multi get it link. This is the way that all these things are connecting, and the FAA. Let me make sure that I'm not kind of conflating issues. That link or that kind of system is FAA approved?
So the multi-link, the radios themselves do not have an FAA approval.
Because they don't approve radios, by the way, everybody. I've had these questions before. It's like, no, that's like more the FCC, but go ahead, keep calling.
Well, to your point, that's exactly it. So there is C-band, right, has been allocated for aviation spectrum, but the FCC is the one that would approve the operational license associated with it. Now, there's been recently some good movement between the FAA and the FCC around the use of that, and someone expects the protection of it and the continued protection going forward. But that's a realm that's handled primarily by the FCC. So what is TSO'd essentially are our transponders and the GPS associated with those transponders. That's where we can pull forward that certification pedigree that we've earned essentially in the crewed aviation space into the UAS space, right? And we talk about that aviation grade capability quite a bit. And when we look at leveraging internally the team that we have to deliver great products and services for our customers, we always try and find the right path that says, okay, does this need to be a certified element, right? And what's the level of trust that needs to be placed in that device for the safety of the aircraft and the efficiency of the operation? And so we manage that effectively there, and transponders certainly is where we've gone off down on the TSO path.
Okay, that makes a lot of sense. I think, Brit, with some of the legislative requirements on cybersecurity, I'm going to just talk for 1 second, blue UAS, green UAS, all of these things. People get confused, I think, right now of, do I certify components with the things like this. So that was a really great explanation that the transponders are TSO certified with the FAA. All of these kind of radio links, that's an FCC lane. By the way, if you care about this stuff, y'all need to be going to my Law Tech Connect next year in Houston, because this is the stuff we talk about. And we did have a space and spectrum panel, Brit, which we'll be broadcasting in the next couple of months. So keep your eyes open, everybody. And by the way, one other thing I want to say is Mark out there in Nevada, looks like you've just kind of secured a partner. So I'll connect you guys offline. But he said he's operating in one of the most mountainous states in the lower 48. We're particularly interested in your assured connectivity program. So there you go. This is why we do the show, to make these connections. And, hopefully you can get out there and work with Mark and his team at that test site. But I want to talk about, we've got like 7 minutes left, which I knew time would fly, Brit, because like I said at the beginning, everybody, they got a lot going on. This AV link, you got it. That was approved by the FAA. So tell everybody what that is.
Right. So we have a primary attitude indicator and directional gyro, TC, which is a supplemental type certificate for use in general aviation aircraft, right? We call that the AV30. AV30 is a multi-function device, meaning it can do a multitude of things. And for experimental aircraft, right, which is a non-certified, non-type certified aircraft, so a home built would be an example of that. For some time, you've been able to take the AV30 and an AV link, which essentially is a Wi-Fi enabler for the AV30, and receive ADS-B traffic from something that's broadcasting it on, say, a Sentry, right? Which is Sentry by ForeFlight, essentially is a little portable handheld device that you carry in the cockpit. We actually make Sentry for ForeFlight. And so you'd receive those ADS-B signals, and then via AV link, it would display that, essentially that traffic on the 3-inch display in your cockpit. So now as a general aviator, you're flying along and you go over to the traffic page, you're like, oh, I see other aircraft and where they are. I see their elevation relative to me. It's that situational awareness that helps improve safety, helps improve efficiency in flight, because I'm only going to one instrument to do that. I don't have to be looking around. I'm not trying to stare down necessarily at at another instrument down there. And I can overlay that on my EFB as well, in this case, ForeFlight in many cases, but other times. well,
Yeah.
what about all those certified aircraft that are out there? And so
Yeah.
it's
I
taking
mean,
a little
that's
bit of,
like I said earlier, like I would assume they had something like this, but
yeah.
go ahead, keep talking.
So they do have ways of being able to get that information in, but what's unique is that the AV Link is now certified along with the AV30, and so you're able to get this called uncertified ADSB traffic, right? So this handheld device that you have in the cockpit that's a Sentry receives that traffic and now displays it on this certified display for you, right? That's a game changer, right? And when you look at now, I have a certified Wi-Fi link essentially in the back of the AV30 that also talks to my EFB. You can start to see a trajectory there that is really connecting the cockpit, right? And we've been telling that story for quite some time about an open connected cockpit, being able to pull together a multitude of devices. It doesn't require you to completely rip and replace the panel, go full glass, do a bunch of cutting, right? It's a 3-inch display, fits in your normal round hole that's already been there before when the panel was first built in 1972, right? Which I'm pretty close to that age, so I know where it goes, right? So that provides that ability for the display of non-certified traffic on a certified avionics, and that's a first, right? And so we're really excited about being able to bring that capability to our customers in the space. It has some other functionality like allowing you to wirelessly update the AV30 itself without having to pull a dongle, take the panel apart. And so that makes sure that we can continue to deliver new functionality and new updates to the AV30, keeps that instrument operating at top performance for a long period of time. And certainly it opens up the door for us on a trajectory that says, well, if I now can talk to this device uniquely between the portable, my EFB, and the AV30, what else can we do there to really enhance what a pilot is able to see and do in the cockpit, especially as we continue to fly older general aviation aircraft in a much more crowded airspace, right? You still have Cessnas out there. They're going to be flying for several more years. And this gives them the ability to really kind of enter the digital world in a way that extends beyond just the panel that's in front of them and starts to capture that other RF information that's out there, whether that be TISB, FISI type information, or the ability to just talk with your UFB and file a flight plan.
Yeah. Well, what about, the drones or, air taxis of the future? How does that, if at all, connect to that cockpit display with the AV link?
Yeah. So there's the concept of electronic conspicuity or conspicuity. Sorry.
Conspicuity, I
Yeah,
know.
big words this morning.
Yeah.
So EC, if you will, or just conspicuity in general, whether it's electronic or optical or some other form, right, allows us to go through this period of CABC, right?
Yeah.
And with AV Link and the way it displays, right, it's one thing like I can see it out the window, but if it's dark or it's cloudy or it's very small, now I can still see it, right?
Yeah.
And so whether I'm in a latest and greatest eVTOL or whether I'm an operator on the ground, right, connecting this airspace is just as important as creating that connected cockpit, right? And so
Yeah.
Christian Ramsey, who's the head chief commercial officer for us, coined the term a while back of connecting everything that flies, right? That's the safety benefit of doing that. That's the efficiency benefit, is that if I know where every node of the network is, right, I know where everyone else already is, it's really easy for me to avoid them. It's when
Yeah.
I don't know where they are that it becomes difficult. And we can
Yeah.
establish right-of-way rules. We can arrive at what's best for the operational conditions and really create a both regulatory environment, technological and operational environment that is best suited for both crewed aviation and uncrewed aviation, remote pilots, unpiloted, autonomous vehicles. All that starts to become possible when we have that correct infrastructure in place.
Well, and, obviously on the commercial side, and then the safety aspects of what you've been doing on the defense side, I told you, everybody, that a lot going on. We're just scratching the surface here. We are like literally 1 minute out, Brit. I want to make sure everybody knows where to find you, because you guys are going to be out in force. First of all, you guys are out in force almost like at every show. Saw you at UVSI Exponential. Y'all were on my stream there. We've got the full crew coming to Energy Drone Robotics Coalition Summit next week. Hope, we'll see you guys there. What else where can we find you? Where can we see you? As we kind of close out the show, I'll give you this last minute, Brit.
Yeah, so definitely catch us at EDR coming up here in June timeframe. We also have the biggest general aviation show happening in July, which is AirVenture up in Oshkosh. You certainly find us there. There's both uncrewed and crewed operators at that show. So it's a great opportunity to engage with us. Later in the year, we'll be rolling off to commercial UAV. And certainly you can visit us at www.uAvionix.com whenever you like, or hit us up at squawk@uAvionix.com. That goes to myself and a bunch of others on the team. And we're always looking for feedback and the opportunity to engage with our audience and make sure that we're doing the right things for the aviation community, right? We are pilots, both, general aviation pilots as well as UAS pilots, and we're in it to make it work better for all of us. So we're excited about the opportunity to talk with you.
Well, thank you so much, Brit, again. Thank you, everybody, for jumping in the chat today. Complex Operations, now you know why they are this month's sponsor. It makes an abundant amount of sense. We're so excited to watch you guys continue to grow and thrive and build this ecosystem that will make not only complex operations safe, but all operations that are happening in the airspace and frankly on the ground. So thank you for what you do, Brit. Thank you for sponsoring this month. It was great to be having this conversation again today. And for everybody else out there, we are out here.
Thank you, everyone.